Welcome everyone. This is the question that is displayed on the screen. It came in the CBSE 2025 set 1 question number 18A and 18B is another OR. So the question is from the chapter optics, from the chapter ray optics. A plano convex lens of refractive index mu1 is placed coaxially in contact with the biconcave of refractive index mu2 as shown in the figure. All curved surfaces of radius of curvature capital R each obtain the expressions of the focal length of the combined lens. Okay, so let us recapitulate what we have learned in the basics. Here two formulas are there. The first formula is the lens maker's formula. Any time of making the lens, any time of fixing the power of a particular lens, the formula what the lens makers are basically taken in considerations, and that is 1 by f equal to mu minus 1 by r1 minus of 1 by r2. That formula is basically the general formula, the lens maker's formula. Another one formula is used for the combined lenses. If two or more lenses are combined with each other, then what is the focal length of the combined lens? That is 1 by small f equal to 1 by f1 plus of 1 by f2. Okay, so this is the thing. Focal length of combined lenses. If more than two lenses, then obviously of combined lens. Okay, so here minus of a divided by f1 f2, that is also there. Okay, but this value of the a is very small, so we can consider that a is negligible compared to 1 by f1 and 1 by f2. So we can use this formula, that is 1 by f equal to 1 by f1 plus of 1 by f2. Now in this problem what is given? Two lenses are given. Okay, two lenses are given. The first one, what I am just marking here, the first one is of refractive index mu1 and it is a plano convex lens. Plano means this plane. I am talking about this plane. Okay, this plane is plane, but whereas this one is the convex. Okay, so that is why it is called the plano convex lens. Now for this purpose, the formula that we need to use here, obviously lens maker's formula, that is 1 by f1 equal to mu1 minus 1, because here the refractive index is mu1. 1 by r1, the surface which is in front, that is the plane one. Since it is the plane one, so we can say it is 1 by infinity, because the plane surface have the radius of curvature infinity. 1 by infinity minus of 1 by r. Okay, so for that we can write it down, that is r1. The value of the r1 is infinity, whereas the value of the r2 is minus capital R. Okay, what is the reason? If you think this point is my optical center, okay, then this capital R2 is taken on the right side. Okay, that's why you can say it is minus R. So if it is on the minus R, then 1 by f equal to 1 mu1 minus 1 by infinity is 0 minus of r. Here is a minus sign, so it becomes the plus r. So mu1 minus 1 divided by 1 by r. Okay, after that, if you think of this one, that is which is the biconcave one, and obviously here the radius of curvature of both the surfaces are same. Clear? So here also, if you think this is my optical center, if you think this is my optical center, then obviously depending on that we can say R1 equal to minus R. Okay, R1 is equal to minus R, whereas R2 is equal to plus R. So according to this, the formula if I write down, that is the 1 by f2, obviously it is 1 by f1, 1 by f2 equal to mu 2 minus 1 by minus of R minus of 1 by R. So this thing becomes mu 2 minus 1 minus of 2 divided by R. So if I want to find it out what is the focal length of this combination, then we can write down 1 by f equal to 1 by f1 plus of 1 by f2. So this one becomes mu 1 minus 1 divided by 1 by R plus of mu 2 minus 1 divided by, multiplied by minus of 2 by R. So obviously 1 by R can be taken common from here. So it will become mu 1 minus 1 plus of 2 mu 2. Okay, no plus. Here it is a negative 1. It is a negative 1. So it is minus 2 mu 2 plus 2. Okay. So obviously here 2 and minus 1 cancels and becomes plus 1. So we can write down it is 1 by R equal to mu 1 minus of 2 mu 2 plus of 1, and that is equal to 1 by f. Now if you want to find it out what is the expression of the focal length, then small f equal to capital R divided by mu 1 minus of 2 mu 2 plus of 1. Okay, so this is the focal length of this combined lens which is shown in the figure. Thank you all.